Howdy everybody in YouTube land. Now that the keypad is done, we have to start working on the driver. So here's the digits. Move all that out of the way, because this thing is a mess right now. A big mess. On top of that, unplug all that because I don't need all these plugged in right now. No, this isn't about SE30s, not this time. People that watch my videos, these boards belong to some of them. I've had them since maybe April, May, and I haven't had a chance to repair them yet. I'm sorry for not being able to get to them just yet, because the summer months are the worst time of the year for me for big projects, for work, and I have to get these done, and I'm still working on them. So, you know, it's just one of those things. So, sorry, I will get to them as soon as I can. Anyway, XP module, I don't need that right now. I don't need that right now. These are the keystone jacks and XP module K out of the old scoreboard. Removed them. RS485 control line. And I don't need those either. Okay. So, what we have here is a Santech incorporated control board that came out of a professional scoreboard, and they're out of business now, and the company was bought out, and we actually have the contract to do the service work, so I have some of these parts as spare. I'm not going to tell you all of what's going on because some of it doesn't need to be known right now. But if you can kind of put two and two together, you can kind of see where we're going with these boards, if you know what I mean. Anyway, so what we have here is the MIC LED driver board, or driver chips. We have an AtMega 128, which is running in legacy mode. The original firmware was compiled with IAR compiler, and it's old as hell, plus all of the operating environments and the program directory path and everything is also compiled into the firmware and put on the chip. Atmel doesn't care where it was compiled from or any of that, but it throws it on the chip and just wastes space. But anyway, this is running in the AtMega 103 compatibility mode because the compiler didn't support the 128 at the time the firmware was compiled. Anyway, here we have a real-time clock chip, and we have an ST7536CP, which is actually a power line modem, which is no longer used anymore because the coil that used to sit there, the coupling coil, is no longer available. So you can't use the modem anymore, and plus you're limited to 1200 baud. That's as fast as you can go, and that is way too slow. So what we're going to do is we're going to do RS485, which is a Max 1487 chip, okay, which is one chip that's used. Another chip that's used is the ADM 483, which actually, it looks like it's part of the board, but it's just laying there. And exposes an 808400, which is actually a digital potentiometer. And what it does is there's a 555 timer circuit and a digital potentiometer, because the way it works to regulate the current of all the LEDs, there's a 24 volt supply that comes in off this main transformer that feeds all these chips. Well, there's really no filter capacitor there. There's none. And the reason why is simple. The 8080, the actual 555 timer is a synchronous PWM that triggers on every hump of the wave, which is 120 cycles a second from a bridge rectifier. So the 555 timer is in sync with that, and the 555 timer actually drives the output enable of those chips. The 808400 is hooked to the 555 to adjust the pulse width of the 555, which is running in sync of the 120 hertz. So the 120 cycles coming in is pulse width modulated to drive the output enable, which controls the current of the LEDs. And the reason why it's set up that way is to eliminate the beat artifacts. So you don't have a beat artifact, you know, like if this light here was modulated, you wouldn't have a beat artifact, you know, of pulse width modulating running at a different frequency of the line frequency. So that's why they did that. But if they were using say a switching power supply with a big filter cap or something, you know, that would filter out to where it's straight DC coming through here, then you wouldn't need this circuit. You can just use the output compare register in the Atmel, which you still can, because you could pick off the 120 cycles here, multiply it up, and just use the timer in the Atmel. I mean, I don't know why they did it that way, but I guess they just didn't know how to use the timers back then. Anyway, so we have a relay for the horn as well, and the horn plugs in over here, which there's no connector for it. I'm going to solder one on. Atmel runs at 3.6864 megahertz, which I might bump that up. I haven't decided yet. So that's what we have. This original driver board is going to run my own firmware. But over here we actually have the digits. These things are insanely bright. 9-inch, I think. Yeah, 9-inch digits. Insanely bright. I mean, so bright you can't look at them directly. So I got a big pile of those over there for testing, and I'm going to use the keystone jack to couple the connection between the board and the keypad. So that's all I have for now. Thank you for watching.